Welcome guys to PVS the tutor. Under chemistry I've got some questions. These are 2019 questions, and the question goes, the diagram below shows atoms of sodium and chlorine. So you know that sodium is a metal and chlorine is a non-metal. Sodium being a metal, it loses electrons. Chlorine being a non-metal, it accepts what? Electrons from a metal. Now A says, state the type of bond that exists in the compound formed when the two elements combine. Now, when chlorine and sodium combine, metal, sodium, non-metal, chlorine, when they combine together, there's a donation of electrons from sodium, that's to chlorine. So we are saying sodium becomes an ion and chlorine becomes an ion. So together they form sodium chloride. And this type of bonding, now that is what you call ionic bonding. So that's ionic bonding, or you can call it electrovalent bonding. And the type of bond that exists between electrovalent compounds they are just ionic bonds or electrovalent bonds. So that's ionic bond. Now they're saying draw the structure of the compound formed when sodium and chlorine combine. So in short, they're trying to say draw the compound sodium chloride. So we need to draw the compound. I'm just going to show the outer shells, of course. So there's one electron in sodium outside there. That will be donated to chlorine. Since chlorine has got 7, you can present that by that. Chlorine has got 7 electrons out there. So this one electron will be donated there, and it becomes what? 8 electrons. And here, the outer is going to have 8 as well here. That's for sodium. So sodium is going to remain this, and the chlorine is going to remain that. So let's draw a compound that is formed. So the compound formed can be drawn like this. I'll just show the outer shells, by the way. So get for sodium. So it's going to have 8 electrons, because 1 electron has already been lost to chlorine. So this is sodium to chlorine, and chlorine is going to have 8 electrons, and chlorine is going to have 8 electrons. So we can just do it like that. So there's an electron that has been shared there to chlorine, and this one becomes a sodium ion, and this one becomes a chlorine ion. So together they form sodium chloride. So this is the compound that was needed to be put there. So next the question says, state the chemical formula for sodium chloride. Now sodium chloride, state the chemical formula. Just this, sodium chloride. This is what they wanted there, sodium chloride. C says, explain in terms of bonding and structure why sodium chloride has the following properties. Why does sodium chloride have a very high melting point? That's what they're trying to say. So something can come up, something has got high melting point when there are strong forces of attraction that are holding the two atoms inside. So we are saying sodium chloride has got very high melting point because of strong electrostatic forces of attraction that require more energy to break. So these, they are very strong. So this is for C1. So these forces are very strong in such a way that they need a lot of energy for them to break. Okay, in the process, making sodium chloride have a very high melting point. Let's go to 2. So C2 says, why does sodium chloride have a high electrical conductivity when in molten? Remember, ionic compounds can conduct electricity only when they are in molten. Now, why? So you can say because once an ionic compound has been put in water, becomes molten, because free electrons, remember electrons are the ones that are responsible for electric conductivity. Free electrons start moving. So the mobility of the free electrons increases in such a way that current or can even say charge within the solution. So that's what happens. So free electrons are now moving, which are carrying current, and they're carrying charge from one point to the other within the solution, and that makes ionic compounds conduct electricity, e.g. sodium chloride. That's an ionic compound. So thank you so much for watching. I hope I see you in the next video. I'm out. PVS the tutor.